and welcome to part 5 of our Key Stage 3 look at energy. Okay, so far we're getting through these lessons now. We're on lesson 5. Previously, the last one we were looking at was the transfer of thermal energy. What we're going to do is continue from there now and have a look at our non-renewable and our renewable types of energy resources that we use on a whole in the world today. So, first things first, what's the difference between a non-renewable resource and a renewable resource? Okay, so non-renewable, we've got here, these are sources of energy that once they're used, they cannot be replaced and will eventually run out. Now, these are things like fossil fuels. Now, they're formed over millions and millions and millions of years. And once they're used, as we said, they cannot be replaced. Renewable resources, these are resources of energy that can be replaced and will not run out. So these are things that are recyclable, are replaceable. But so we'll go into these a little bit more depth through the course of this lesson today. So as we move on, let's have a first look at what our non-renewable sources are. So here we've got a picture of an oil well. So now basically non-renewable resources are also known as fossil fuels. Now these are ultimately linked back to the sun. Now what they're caused for is from the remnants of dead plants and dead animals that have been subject to high pressure and high heat deep underground. Now these then source, basically as they decay, will form several different types of fossil fuels. It could be coal, it could be oil, it could be natural gas. Now this form of energy is used by and far by most countries to far outweigh renewable energy, and this is the issue with it. The problem is that it takes so long for it to be formed under the ground. It takes millions and millions of years for it to form, so eventually we will run out of this because it takes so long for it to be replaced. Also on the other side of it is that although it's a really, really good source of energy and it's fairly cheap to obtain, it holds very, very big environmental issues in terms of the fact that it produces lots of pollution, as well as to actually get it from the ground. It causes big, you have to dig very, very deep into the ground to be able to get it up. Large areas of land will be destroyed in able to get it. So that's basically non-renewable resources. They're fossil fuels, and once they're used, they cannot be replaced, apart from over millions and millions of years. So as we move on, we're going to have a look at our renewable resources now. Now this is just 3 of the types of renewable resources. We will go into furthermore different ones in our following lecture on saving energy, but these are the main 3 at the moment. Over here we have wind turbines, which harness energy from the wind, as the name suggests. Over here we have solar cells, which directly turn the rays or the heat from the sun directly into electricity. And here we have something which is called hydroelectric. It's a dam, and that harnesses energy from moving water. So what we're going to have a look at the 3 of these more individually as we go on now. So first of all, wind power. So how does wind power work? So what we do, we have this thing which is called a wind turbine. So basically a windmill. It's a modern day windmill. So as the blades on the wind on the turbine turn, this is due to the wind. Now, wind is caused from convection currents, as we were talking about in our previous lesson on the transfer of thermal energy. Okay, wind is caused from convection currents. So as this passes through our windmill, the windmill turns. This itself is what is called a turbine. This itself is then connected to a generator, which is inside the turbine. As that spins, that creates our energy. That converts our energy, our kinetic moving energy, into electricity. Now the good things about this is that obviously in certain places it's always windy, but the problem is if it's too windy, the windmill can end up damaging itself, and obviously costs more money to replace. Now the downside is that if it's built in somewhere that there's only very little wind or infrequent wind, where it's not windy all the time, then obviously it's not going to produce the energy that we need. Also at the same time, if you compare this to burning fossil fuels, the energy it actually produces is far less than burning fossil fuels. But obviously you don't have any downside of pollution. So what's our next? Our next one is solar. Now there's two main ways in which we actually harness energy, or harness energy from solar activity. There's solar cells and there's solar panels. So if we first look at solar cells, which is what we have the picture of here, these little cells, what they do is directly take the heat and the rays from the sun and convert them into electricity. They're a brilliant invention. But the only downside to these is that obviously at night time there's no sun. So at night time you don't produce any electricity. And as long as it's in a place that's free from clouds, which let's be honest, here in the UK we have a lot of cloud, so it needs to be somewhere where there's always constant bright sunlight. The other one we were looking at was a solar panel. Now the way that this works is actually a series of tubes which feed through cold water, and what that actually does is directly take the heat from the sun, warms the water, which then itself creates energy within that warm water. As I said, it's generally only used for water systems. You'll find them generally on the top of tall buildings, used in offices and things like that. So our final one we had of the three that we were looking at is hydroelectric. Now hydroelectric, otherwise known as a dam. This is the Hoover Dam in America. It's one of the biggest dams in the world. It's certainly one of the most iconic dams anyway. So what we have here is the wall of the dam, and this is our river going through here. Now as you can see there's a big drop from the top of the river to the bottom. This is what this dam does. It restricts the flow of the water as it comes through. So our big pile of water that we have here, as if you remember going back to lesson 1, and previously mentioned in other lessons as well, we're talking about gravitational potential energy. So this big water store here is full of this potential energy that's just being held back by this concrete wall. Now at the bottom here we have our small tube, which in itself has a turbine in it. So when this is opened, the water with its potential energy shoots through that turbine and comes back through here. So that potential energy has been converted into our kinetic energy. And once again, same as with the wind turbine, as the turbine spins, this is connected to a generator, that generator spins and in itself produces the electricity that we all use on a daily basis. So again, as I said, it's just converting gravitational potential energy here behind the dam, moving it into kinetic energy, which through the powers of turbines and generators, we then produce electricity. Now, with this, again, against fossil fuels, this will never run out. The water will always run. Same as with the wind turbine, the wind will always run. With the sun, generally on a sunny day, the sun's going to be there, so we're always going to produce energy from here. The downsides to dams, they're environmental issues, but again, no pollution. So, as we were looking before in lesson 2, we were looking at energy transfer diagrams. So just trying to actually get this across as to how you can actually use those transfer diagrams in any sort of different type of energy production and energy transfer. We've got one here for our dam. So as I said, we have our water behind the dam, which is a store of gravitational potential energy. Okay? When the turbine is opened and the water flows through the pipes, this itself means that the potential energy has been transferred into kinetic energy. Okay? So as the water flows through, it spins the turbine, which again is then another transfer of kinetic energy from the turbine into the generator. This generator again itself then spins, so therefore the spinning kinetic energy of the generator is transferred as electrical energy, which then obviously goes into our power lines. Now, in saving energy, in the next lesson, we will actually look at exactly how that works and what actually happens before it reaches the power lines and before it gets into your home. But as I said, in the next lesson from this, we will have a look at that. So briefly we mentioned there's another different type of renewable resources. This is called biomass. Now, the way that biomass works is that it's actually the burning of woods, of grass, of hay, of animal waste products, which is a very similar process, a very similar power plant to how fossil fuels work. Again, in the following lesson, we will actually have a full look at how power stations actually work. Again, it's very similar in terms of turbines being linked to generators. Now, the thing with biomass is that it's classed as renewable because although we are using wood and we are using a resource, we can replace it, because as long as we keep planting as many trees and as many plants as we use, then obviously that is continuing to the point, as long as it's managed correctly, the resources will never run out. The downside to biomass, again, although it does create some pollution, nowhere near as much, or not as much as fossil fuels, but it itself does produce pollution, but it is renewable. So our overview, what we know is that fossil fuels are non-renewable and will run out. You know, they are replaced over millions and millions of years, but eventually they will run out. And as the moment in most countries, it is heavily the biggest source of energy and electricity that is actually used. And renewable resources are replaceable and will not run out. It's important to note the difference between reusable and replaceable. Okay? Renewable resources are replaceable, especially in biomass. You know, we can replant to replace those sources. With wind, it's replaceable because there's a constant flow. Again, with hydroelectric, there's a constant flow of water, so it's replaceable. But once it's gone through the system, unless there's a full circle, it's not reusable, but it is replaceable, and they will not run out. I hope that has helped on this section of energy. And so, my name is Ian McDowell, and I'm a student at Brighton University. Thank you.